Hello everyone, Quentin here from Sphero. Just like most of us, I'm home working from there and learning from there. This is the third part of a mini-series, and today we're going to be talking about electrical engineering. So if you've been following the series so far, we've been talking about how the robot is kind of like the human body, and pursuing that analogy, today we're going to talk about 4 parts. So the first one is the batteries. We're going to talk about how those provide energy to the robot and how charging is possible. Second, we're going to talk about the power distribution of the system, so how the robot gets power from the battery to the motors and stuff like that. And then third, we're going to talk about the sensors, so what allows the robot to make decisions real time. And to finish, we're going to talk about the PCB, the printed circuit board, and kind of the electronics behind it. So let's get started. Electrical engineering. To me, that work is all about finding the right components that are going to go in the robot and then connecting them together. So you have to understand what the application is, what you're trying to do, and then from there you can just pick the parts that are appropriate, find the right battery, basically connect them by creating circuit boards or using some wires, some jumper cables. And some of that comes into multiple phases. So first, you have to prototype everything, so you get some specific boards, like the breadboards. I work a lot with those, where you just put your components and then you make sure that the circuit works. And then you turn those boards into a PCB design, like this one, for instance, that doesn't have components. And eventually, the last part of your job is to put the components on top. And that becomes this, right? This very complex printed circuit board that has all the features and everything is connected in the proper way. So we're going to dive in a little bit the different features, starting with the power system. All right, let's see about those batteries. So you're very familiar with those kind of batteries. So, the AA's, the AAA's, and the bigger ones. So those are non-rechargeable batteries, but they're also what we use for the robots, rechargeable batteries. This is a LiPo. And then for those of you who have a rover at home or at school, this is a rover battery. It's pretty big, right? So depending on the size of your robot and how powerful your motors are, you're going to need a bigger battery. So the bigger the robot is, the more energy it will take you to move it. So you're going to have to find the right amount of energy for the lifetime of the robot. So if you want your robot to drive for an hour, you have to have a bigger battery than if it only needs to drive for 30 minutes per charge cycle. So speaking of charging cycles, you might have noticed on the rover battery that there's this little USB connector here, USB-C. And this is like the second important part of the battery design is, what are you thinking for charging? Like, how are you going to charge it? You probably know from your phone that they can charge with a USB, but it's not always the case for all the robots. So for instance, we have the Ultimate Lightning McQueen that we had to have a special adapter that provided more voltage for the robot. Depending on your application, you're going to have to pick the right battery. Think about it as if you are an adult, you have a bigger stomach than if you are a newborn, because your energy needs are different. And if you are a newborn, you have a smaller mouth, a smaller charging cable than if you are an adult as well. So really the sizing of the battery and how fast you want it to charge and how much capacity there is overall really depends on your application. Okay, so let's talk about now how to provide that energy to the motors and to the rest of the system. So when you activate your muscles, they need a lot of nutrients to actually operate. And if you start running, your heartbeat is going to go faster. So you're going to be able to provide more energy to the robot. So it's kind of a similar thing on the robots themselves. When your motors are actually turning and driving and providing a lot of effort to get over a bump or to drive fast, you have a system called a motor driver that actually provides the energy directly from the battery to the motors themselves. And that system is very specific because it is controlled by the processor, the brain, but the logic, the circuitry that connects the brain to the motor driver and the motor driver to the battery is slightly different. So that you have some safety in place. So it's a very similar, the motor driver provides the energy to the motors. It's kind of like a heart and the vessels, right, to go to your muscles. Now, the other organ that takes a lot of energy is actually your brain. So similarly speaking, there is a part that is called an LDO that converts the energy from the battery to the brain, and it's done in a way that it doesn't overflow the brain with energy. It's done in a way that it reduces the voltage and keeps it constant to make sure that the processor and all the logic on the board works at the same voltage. So those are the two important parts for the power distribution, and that's kind of like the heart and the blood vessels of the robot. All right, next is my favorite topic, the sensors. So what is a sensor? Well, let's talk about the human body first. So when your eyes are seeing something, they take the light from outside and then they convert it into a signal that your brain can interpret. And for instance, if you're seeing the color blue, there are some cells in your eye that are activated and to tell your brain this is the color blue. We have exactly the same thing in electronics. There is a color sensor that is sensitive to a specific color of the light, so blue for instance. And when it sees a lot of blue, there's a lot of current that flows through the sensor. So the microprocessor is able to actually see that signal and then take that input and then do something with it. So many of the sensors kind of work in a similar way. There's a physics phenomenon that is happening, and they convert that into an electrical signal that the processor can interpret, just like the brain. So what kind of sensors do we have? Well, if you take a look at Rover, we have actually many kinds of sensors. So we have a sensor for the color. So we have a color sensor underneath the robot that can detect the red and green and blue components of everything that's underneath and then tell the brain what it sees. We also have some infrared sensors. So those allow the rovers to kind of talk to each other. Think about it as an infrared emitter, a diode, which will be a mouth to speak. And then you have the infrared receivers, which are kind of like your ears to interpret the data, to interpret the information. So we have a few more sensors. We have sensors for the wheels, so we know how fast the wheels are spinning. And that's really important to control the speed accurately of the robot. And then I think one of the most important sensor of the robot is the IMU. So that stands for inertial matrix unit. And what that means is it's an accelerometer and a gyroscope. Because of those combination of sensors, it knows first how fast it's accelerating. So if it's driving one way or the other, kind of think about it as your internal ear. If you were to close your eyes and then kind of like lean one way or the other, you're still able to understand what's going on and to correct it so that you don't fall. So that's the accelerometer. It's the same thing on the robot. And then there is the gyroscope, which basically allows you to know how fast you're turning around yourself. And that information can actually be used to know your orientation. If you were to face one direction and turn 90 degrees, like you always do in your programs, I'm sure, you're actually going to be able to detect that thanks to the gyroscope. Think about it as your internal ear. It's a very powerful sensor that the robot uses a lot to make those beautiful trajectories, right? That's basically the sensor that allows you to drive in a straight line, which is a very, very important thing for a robot. So there are plenty more sensors, temperature sensors, pressure sensors, and we have some of those on the robot. The last one I didn't mention so Rover does not have a pressure sensor, but Rover has an ambient light sensor that allows it to know the amount of light that is nearby, which is also helpful in many situations. There's a large variety of sensors that we have on board, and there are a lot more to explore after that. Those are really helpful when the robot is trying to make decisions on what to do, when you're trying to provide it some autonomy. It's like, oh, well, if I see something on my color sensor, if I see the color blue, maybe I'll want to go forward or something like that. So that was for the sensor part. All right, this is the fourth segment and the last big topic of the video, how to make the printed circuit board, the PCB. So you can see here I have a lot of components. It's a very busy board, so this is, for the record, this is the board that goes on the bolt. You can also see the board on Rover like this. you can see the PCB, and that's actually one of them because there are multiple PCBs on the robot. But how do you get there? How do you make that? And kind of what does this serve the robot? Well, I like to think about the PCB as this is your nervous system. This is your blood vessels too, but it's kind of what relays the information, kind of how your brain is able to talk to your muscles. It's kind of how your brain is able to talk to your eyes. It is through that circuit board where everything is placed together. Now, we have to work a lot with the mechanical engineers with this because they tell us how much room we have to make the board. So, the board is a specific shape for a reason. It's not usually left up to us to decide what we need as far as space. We just have to make sure that there's enough room for us to fit everything. And then from a programming perspective, we also work a lot with the people who write the code, the firmware engineers and the software engineers at the company, because they tell us what they need from an electrical perspective to actually write all the features, and we pick the right parts to support that. So, we use some design software to design those boards, and then they're sent into a manufacturing company that can actually build those, with proper materials. So, you design the board, and then you get those circuit boards that have no parts printed. And you can see there's some little pads here and there with little holes. And those are meant for you to actually solder parts on. And those parts, once they're actually placed, it kind of looks like this, very busy, very populated. So that's a lot of what we do to create the PCB. And then from there, once you get the board with all the parts, the final step is to test it. Is that going to work? And to test it, you have some tools. You might be able to recognize this. This is a multimeter. There are a lot of them in schools, and I've studied with them when I was back in school beforehand. And those are great. Those are great tools to actually find if there are some issues with your board, make sure that all the connections are right on your printed circuit board, and you get to debug on the fly the hardware. So that's very interesting. Once you're sure that the hardware is going to work, you power it on and you give it to the firmware team. And that will be the topic of the next video, how you write code for the robot. So they'll take it from there. All right, everyone, that is it for today. Thank you so much for tuning in. If you have any questions, comments, or any other ideas for future videos, tweet us at Sphero. We will be back next Friday for another video, but until then, keep making, learning, and building.